Well, thank you very much. And, oh yes, what a lot of technology was actually covered in that previous talk. So it sort of, I think, upstaged me quite a lot because mine is meant to be about technology opportunities. But I'll take a slightly different slant at it, which I hope will be useful. Let me skip over the first couple of slides because you know all of this anyway. I'm going to go straight to this one. A bit of scoping the problem, because I'm going to put myself in the space of a technology company, an SME, who's into sensors, information processing. And they're going to ask, all right, how big is this problem? What does it look like? I'm asking a few questions. So first thing, of course, is the scale problem. You know, is this out in the field? Is it in a Petri dish? Now, for animals and fish, maybe not Petri dish, but certainly different approaches, different sensors, maybe for asking the same question according to where it's been asked. Next thing is the traits you're looking at. Now this is a really useful thing I've stolen from TSP. Someone's classified things into easy down to very difficult. And I thought it would be interesting just to think out loud a little bit and ask, how could we go about this? What sort of technologies are out there, some of which have already been mentioned, some of which haven't been, that could give a heads up, this is a sort of approach that could be taken, and hence, what sort of company do we need to use to access? What sort of skills do we need? But I actually want to, this is something I didn't talk about when I did this talk in Cambridge 2 days ago. Part of the problem is the stakeholders, the sorts of groups, particularly SMEs you want to put in. Let me say something about the sensors and instrumentation community. Now some of you here, of course, are in that community, but particularly for the academics. It's very much a long tail. Down at the sensor end and the integrators of sensors into some sort of instrument, it's basically small companies, 20, maybe 30 people, a couple of £1 million turnover, and that's just the way it is. You go along to the bigger companies, you find there are actually relatively few. You know, the GEs who maybe have 200 or 300 technology capabilities in sensors, which they've acquired largely through acquisition over the years, but they're the small set. The vast majority of innovations are coming out of small groups. And the domain knowledge point is actually the key thing. The way they operate is, they've got some instrument that maybe came from a university or they've worked out themselves, and they've made a business out of one domain, be it measuring water quality in a sewer, or in a water treatment plant, or measuring gases down a mine, or something like that. They know that domain very well. They've managed to tweak their instruments, their operating conditions, the skills of their staff in saying, it isn't working because of something that no one knows who hasn't been down that mine or crawling around in that water treatment plant for a while. So that is really where their key capability is. It's not so much in the instrument itself, it's in the knowledge about how to apply it and tweak it for that particular application. So you'll often find the same sensor being used in 15 different ways according to the domain it's been applied in. Now, why am I saying this? I think because if you've got a technology problem, you want a sensor to do X, what you need to do is ask the question, what sort of commercial group is going to have the skills, the sort of domain knowledge I need, and might have a technology as well that they can apply to it. So it's not just technology, it's who's in there. So to give an example, animals. They're out in the field. You need someone who's used to doing instrumentation in a dirty, horrible environment. It's as simple as that. So you don't necessarily go to GE, because they do the things that you stick on walls here, or in aircraft, or maybe in a power station. Maybe you won't go and talk to the guys who do things down mines, where it's dirty, hot and sticky. Or in the sewers, there are lots of those, and so on and so forth. So think about who you approach and why they should be interested in your challenge. Because they're looking for an adjacent domain where their skills can be exploited, and that's part of their protection in their business case. I can get in there and do something that other people can't, because I've known something about it already. Now, exploit your network, please. If you know someone business who's already working in your sort of world, even if it's not the technology you want, then ask the question, maybe they know someone who can be useful to you. Or, if you find a company of interest, ask your friend, talk to them, give them an idea what the world is like that they're entering. Because they won't be switched off by their technology, they'll be switched off by the fact that there's no one there I can talk to. I haven't a clue what this community is like. And of course, last thing, the business return and risk. Most of these small companies make their money from running a little production line, normally here in the UK, because they're desperately making sure that the skills, the knowledge about how to design their instruments and set them up or operate them isn't stolen. And that would happen if they decided to outsource manufacture to the Far East or something. So they do it in-house, here in the UK, in little operations, and they make their money through repeat manufacture of instruments and sensors. That's what they want to do. That's what keeps them turning over. But they're looking for some protection. So if there's some IP that they can license or come to some sort of deal, that's great. Give them something. The other approach, of course, is just to keep it utterly secret, and that's used as well. So, I'll move on to sensor system. Now, this picture on the right has been stolen from the Scottish Sensor System Centre, the S3C, which is Glasgow and Aberdeen, and thanks to them. But I find it quite useful in saying, system problem. Down at the bottom is the thing you're trying to measure, the real parameter or a proxy for it. And there's a sensor element. And we've got a bunch of things here. Earth observation, chemical and gas sensor, strain, imaging, fine, there are hundreds of other opportunities. But a key thing is, how do you acquire your sample? No, do you physically get in contact with the subject? Is it a standoff? Do you do it once a day, once a week? How much? That's actually something that you need to give some sort of clue to these guys. Automation, do you need it? Often you do, but that's a big issue. And you're going to acquire loads of data, and that's the biggest problem these days in making value out of these sensors. There's just too much data, and no one has the time to sift through it and work out, what does this tell me? So it could well be that an early focus on how do we pick out the meat from the dross in this data set is an important part of your proposal. Integration, well, putting it together into a package that will work, is important. And then I'm going up this tree from data to information. Up at the top, the red bit, which has sort of been highlighted, but I'll make it very explicit. It's no use to you if you, as an individual manufacturer or an individual business, can come up with an answer and say 5% protein, for example, in that object over there. It's no use to you if other people don't believe your number. So you need a framework that everyone can accept, where decisions have been made according to rules. There's traceability, as has been mentioned, and people have some sort of measure of confidence in the number you've come up with, something that people can accept. The example I always give is the meter rule. We all believe them, but that's because we sort of know that there's a calibration path back to the standard meter, the one in Paris. Okay, a few examples. This is one that was given to me, and probably some of you guys know it. It's not to do with animals, to do with plants. You grow a plant between two plates, and the roots, of course, extend downwards. Image it in a variety of spectral bands, and I don't know whether you can see this very well. Different information is available about extent and what the root looks like. But now, some thinking out loud. Now, I looked at that list I showed you earlier. Let me show you, it was that one. And I thought I'd pick out some of the difficult and expensive traits, a difficult and sporadic trait, and just think out loud, how could you attack one or two of those without particularly knowing the details of the problem? Measuring behaviour. Well, there are actually several people in the room who know about using video techniques to track objects, to characterise them, to look at their behaviour. It's well established, it's been used for shopping and queuing behaviours in Tesco's. If any of you ever go to Tesco's, walking around railway stations to look for bottlenecks, that kind of stuff. Security and crime, after 9/11, loads of money went into that. And of course this standoff detection could be integrated with wireless tracers, whatever, in order to give you really wide-scale information on where the subject is, as well as what they're doing. Plus, of course, you can bolt on motion sensors and the like to give you real macro information about how they're moving. So all of that is doable. There's a Wii handset, and there's a little piezoelectric polymer thing that can be strapped onto something very, very low cost, commercial off the shelf. Now, moving on now, drought resistance. I thought, how do you do that? Okay, you've got commercial off the shelf soil conductivity sensors. And my excuse is, this is again a plant example, but hopefully the case will give you an idea. Lots of image-based change analysis can be applied though, if you're observing something. No, my starting point, if Facebook can spot your face in a crowd, then we can spot an individual plant or an animal and maybe show what's changing. Now, indicators, well, here's a difficult thing in the imaging world. They don't want to do anything that is affected by colour, because colour's terrible. It's really hard according to, because the lighting affects things. You want indicators like the number of vertices, the number of crossing points, the length of an element, things like that. Things that are easy to pick out from an image. Down at the bottom I mentioned, well, how about introducing tracers? Is it possible in some cases you can put in something, as they do in medical ultrasound, that give you better contrast and more information about what you're looking at? It may not be possible except in the research lab, but something to think about. Now, two more, I think, composition. I'm thinking here about food that's actually somewhere in the supply chain heading towards the supermarket. So, supposing you wanted to look at water, fat, protein, all this kind of stuff. Now, at the moment, you do need an array of analytical techniques. It would be done in a lab, typically. But there's a lot of work happening in integrated biosensors to try and intelligently combine the outputs of several sensors and say, this is the story. I may not be able to tell you it is this, but I might be able to tell you it is of a type that is either that one, or that one. And that one over there is probably the one that's healthy. So, the EPOS project in Europe, that's an FP7 funded project, has done a lot of technology road mapping in that sector. And if anyone's interested, I could point you on the website. I'd also, quick plug here, mention the ESP KTN directory, which we've done on biosensors activities in the UK. So if you're just asking yourself, who does biosensors? We have a book that can tell you, which you can download from our website. Nanomaterials, also a key thing. So my last thinking out loud one is nutrient use efficiency, where I had to scratch my head for quite a long time. Now again, I was thinking about plants a bit here. Water, minerals, light, those are the inputs. But the problem is you also want to measure the outputs, and that's the different thing. Now, if you're looking for gases, there's LiDAR, infrared techniques that can do standoff detection of gas concentrations in their presence. Okay, let's sort of do that. If you're looking at the mass fraction, then there are well-established microwave and infrared and X-ray techniques that are used in other domains to work out the composition of an object and might be able to give you some idea of how much of that mass is not water, for example. It's all about the matrix analysis. An interesting one, in aerospace terms, every lump of metal that's filled before it goes on an aircraft will be analysed by a little handheld X-ray probe to make sure that the elemental content is what it's meant to be. Is this the right element before I bolt it onto the aircraft? Now, is that going to be valuable maybe to people who are looking at the mineral uptake of a plant or something in the animal domain? I don't know. But it's commercial off the shelf out there. And I'll mention LEDs at the bottom just because there's a sausage connection. We talked a lot about gas sensors, but there's some new technology based on light-emitting diodes that is now being used for carbon dioxide and methane detection. And the model there, of course, is if you can get onto the semiconductor bandwagon, you can start to really reduce costs and extend battery lifetimes. Now, Amgas, who are, I think, in the Midlands, and GSS, who are close to Glasgow, they've been doing this for particular application sectors. The first one is oil and gas. The second one is actually kitchens, typically, to find out how much carbon dioxide has increased above burners to keep the staff safe. But they possibly are the sort of group who could really cost reduce gas sensors down to a point where it could be applied in very large numbers out in the field. So, last thing about how we work with biosensors. Obviously, we know about electronic sensors and photonics. We've got 4,500 members, I think, across all domains. Please contact us if you're thinking, I need a technology like X, or maybe I need a company like X. I don't know what technology I'm looking for. We talked to Materials KTN and the nanomaterials guys, because materials are key to sensors. ICT, of course, are key links as well because of the information processing. And that's why we're working together. So, I'll finish now. These are the two names, myself and my colleague Alex. If you've got any questions, feel free to contact us offline.